afternoon, everyone. I am Ranganathan, the CTO of PlanetWorx. I would like to start this conversation by thanking AWS for making this happen during the pandemic. Your story team and finally the jury for taking this time to watch these videos and for actually being here. Let me start by introducing the team. Girish is our official designate CEO. Anil plays the role of COO. We also have Amar, Hemant and Anil who form part of the engineering and the product team put together. Anil, I went to school together. I mean the Indian version of the school, not the American version of the school. Girish and Anil used to work together for many years at Infosys and IBM. Finally, sometime in 2017, we decided that we had enough of our cushy jobs and take the plunge with PlanetWorx. So as to what we have done so far with our company, we have signed contract with major OTT players, news aggregators, DMPs, and a couple of keyboard applications. In terms of traction, we've just signed a term sheet for raising about $500,000 with a valuation of about 4 million. So now that we have done with the introduction, let me tell you about Trapyz, the product platform that we have built. It's an audience insights platform that uses location and device telemetry at the core to understand the user's offline behavior. Where is the offline behavior used? It is used by the media apps to understand and monetize their own audiences better. If this is sounding a little complicated, so let me give you an example. So first thing when I want to buy a car is actually go online, look at all the details of the car, compare the car with the car that I actually want to buy, right? But the guy who actually intends to buy a car would actually drive down to a car showroom, look at the interior of the car, look at the exteriors of the car, and then maybe even take a test drive. This is what when I mean real intent is, right? Offline intent. This is what Trapyz is all about. Okay, so now that we have finished describing what the product is, right? Let me talk about how we actually do it. Whenever I hear the term architecture, the thing that comes to my mind is evolution. It could be in terms of a temple architecture, or it could be in terms of building architecture, and finally even software architecture, because it's constantly evolving. It has started from certain things and has evolved into certain things what we are today, and I am sure it will continue to evolve as we add more features into the product. Okay, since I've called this an evolution, I will try and explain this analogy to explain how we have done and what we have done and how we have arrived at this juncture. I will try and keep this simple, and I hope you had an opportunity to go over slide number 5 where I have outlined the architecture. The pipeline that we have today is what I have presented in the slide, and I would like to split this into 3 different parts. The number 1 would be the seamless collection of data and storage. Number 2 would be the transformation of the data. Number 3 would be the presentation of the data. Let me start with number 1, right? The collection of the data. This would start with an Android SDK, which basically collects logs at a fixed interval of time, and at the same time, it would also collect what the device was doing at that particular instant. Say whether it was actually moving, whether it was on a vehicle or it was running. This would basically help us eliminate the false positive for a location visit. So once we got this functionality working, we had to start writing this data into some place, and the next thing to do was to create an API endpoint. We had our own API in the beginning with an EC2 instance, and generally we were not happy with the result, which is when we decided to use Lambda. Lambda is a serverless compute and highly scalable function. So we created 4 Lambda functions with an endpoint for each one of them and ended up writing these logs into a Dynamo table directly. Very soon we realized that writing to Dynamo table was not really very efficient because Dynamo is very expensive and we had to minimize the number of reads and writes. This is when the idea of using Kinesis and Firehouse came about. Instead of writing to Dynamo directly, we used the same Lambda functions to create a data stream and started writing this asynchronous data into an S3 bucket at a 15-minute interval. This helped us scale tremendously and also helped in the creation of another pixel, which would be a replacement for the SDK, where you'll still be able to use the same data stream to write to S3. And this was basically for publishers who did not want to integrate a third-party SDK into their own app. Having taken care of this SDK, we had to make sure that this SDK was actually easy to integrate and battery efficient. And to prove it actually, we developed an app of our own using the same SDK and got real-world feedback on the data that we were actually collecting. The second part of the pipeline was the transformation of raw logs to visit. So how do you take these logs and match them to places or points of interest? Initially, we used something called GeoRedis and Node.js API to match the locations to the logs. We had a humongous Python script which processed every log to places, and for logs that did not have a match, we generally tended to ignore them. We also wrote every match log into DynamoDB. At this point of time, we had about 1 million points of interest, and the efficiency kept going down as we added more points of interest and actually more devices. To get better, we finally split the transformation into multiple parts. By this time, we had over 6 million points of interest and we needed to process them really very quick. So we decided to use Go, and this was such a blessing because it brought down the transformation of data lat longs to points of interest by about 1/10 of the time. Also, this presents us an opportunity to solve the moving window problem, and that is where we wrote our Parivartan, right, which is called Parivartan, and the core of the product started to play out well. To explain the moving window problem, I would like to take an example. Say device A actually went to a Hyundai showroom at a time T. Then the same device actually walked around, took a test drive for about 20 minutes, and the next log that we actually got from the same device was at a time T plus 20, but in the same showroom. Means the device was there, and so on. This is where actually Parivartan took logs for each device A at a time T, calculate the dwell time, associated the visiting to a particular place for a higher percentage, eventually writing the final transform data into Dynamo. This gave us the opportunity to say what the dwell time and the probability that the device A actually was at a point interest P at a particular time T, and that was how we actually went about creating Parivartan. Now that we had a way to transform data, we needed a better algorithm and to make the visitations right and get the probability much higher for a particular visit. That is where actually having Parivartan helped, right? We actually could change the algos without actually changing the pipeline. And we started getting better feedback from the clients, and the data started getting better. And we didn't have to change much again in the pipeline. So we had to tweak Parivartan, and that generally gave us better results. Having solved the Parivartan problem, we needed to make the data available for different kinds of aggregation, right? So basically people wanted to do different things. For example, how many people are visiting Hyundai showroom in a particular month, or how many people are actually visiting a particular showroom at a particular time. Reading all this data for aggregations on Dynamo really became very expensive and very tedious also. So the next step in our evolution was to add Elasticsearch into the pipeline. We initially used an AWS managed cluster, which actually helped us get the results very quickly. Once the results actually were in our favor, we decided to build our own cluster using Salt as the configuration mechanism. Using Salt helped us scale up or scale down quickly based on the data that we were actually getting. We were able to create multiple tables, indexes, and helped us keeping one client data from another. Basically means we could actually create an isolation. This also meant that we could run as many number of queries without having to pay for each query. So finally onto the data presentation. Now that we actually built an entire house, we need to make sure that the finishing was actually equally good, right? Actually, you guessed it right. The user interface which defines the solution irrespective of how good the structure is. We kept the UI minimal and quick to use. We ended up actually implementing a query builder for our customers to build their own segmentation, and we also added a predefined segment so that they could actually get something of a bird's eye view. Also, we presented them with some facts on the UI where the top visits were really happening, what categories the customers were visiting, what subcategories they were visiting. The user had the option to do whatever kind of query that he could think of, right? And he was only limited by his own creativity. To finally give you the numbers, we are processing about 25 billion logs for about 60 odd million devices and for across 600 cities. We are constantly improving the accuracy at the same time and constantly building new algorithms using Parivartan and supporting thousands of queries for every customer that actually comes and visits our website or uses our APIs. Thank you for this opportunity for being able to present here, and I'm open to take any questions that you might have today.